大変長らくお待たせをいたしました。ただいまから NVIDIA テクノロジーセッション、セッション3 Graphics in the Cloud を開演いたします。Please welcome NVIDIA VGX Product Line Manager Will Wade.
Thank you. Thank you. Great. Thanks for having me here this afternoon. I'm really excited. Today we get to talk about a brand new product line for NVIDIA in the VGX product line. So this is a new adventure for us, a new exciting technology, and we're really ready to bring this to the market. So let's jump right into it. Like I said, this is a brand new idea. We introduced this a couple months ago at our GPU Technology Conference in the United States, and I'm glad to bring it here today. You know us as a graphics company. That's where we started out. We built graphics processors back in the 1990s. We built that into a gaming PC world. We grew that into the workstation space and professional use cases, and it was an awesome business for us. We then transformed our company into a computing company. And there's a lot of people here today learning about GPUs for computing. That's our Tesla business line. So that was the first major reinvention of our company. Now we're on that third wave where we're going to take these graphics, apply what we've learned with our Tesla business unit, and take those graphics to the cloud. Okay. So here's what's driving that use case. This, what we call the bring your own device mentality. All of us as employees now have several devices, whether it's a cool tablet device like our Tegra 3 tablets, whether it's a phone, whether it's a laptop. Everybody wants to use their favorite device all the time, whether it's personal or work. There's a big blending of work and personal life, and we want to be able to work when we want to and be able to enjoy our life when we want to. And as a result, we want to do that on all the same devices. So we want to have our tablets accessible for work. We want to have our Mac accessible for work, if that's what we want to do. And of course, we want to have our standard PCs accessible for work. But this creates a challenge for our IT departments. Enterprise IT departments don't like to support multiple devices. Right? They want one standard PC that they can support for everybody. Okay, so how does an IT department do this? Well, you take all of these different client devices and you allow employees to bring their own device. You know, maybe you supply your employees with a thin client at their desk, right? And then the employee can bring their tablet or their phone or their favorite laptop device and connect as well. What IT does is support the virtual desktop in the data center. So you build one image of your OS, you build one image of each of your applications, and you build one data storehouse in the data center. And then when the virtual machine boots, you combine all those pieces into this virtual computer in the data center. Right? All of that is delivered to your client device as an application. So just like game companies deliver Angry Birds to your iPad, we can deliver an application or your work PC as an application on those devices. Right? And now you can use any of those devices to connect to your work PC at any time. So if you're in the office, you connect from your thin client. If you go to a customer to visit and show them your data, you can connect from your iPad. And you go to home and work, but you forgot something to do at the office. I just want to check this one email, or I want to change this one design. You pull out your phone, connect to that work computer, just like it's an application on your phone. Okay. So these are our brands for GPUs in the cloud. Right? Tesla is our computing brand, and that's by default cloud enabled because it's already in the data center. Right? VGX is what we're going to talk about today. This is for your remote PC and workstation in the data center. VGX is our professional brand for the data center, targeted at enterprise people that use this at work. GeForce Grid is our third brand for the data center or for the cloud. And GeForce Grid is our gaming in the cloud brand. It will leverage our GeForce product line, but it will be specifically designed for data center support, 24/7 reliability. We also support Tegra. That's our SoC devices or system on a chip devices. We support Tegra as a client access device, and we have Tegra, like I said, in all kinds of devices that people carry all the time. We don't require Tegra as a device, as a receiver device. We'll work on anything, iPads, Tegra-based devices, x86 PCs, Mac PCs, but we do support Tegra as our client device, and we have some optimized technologies that can make Tegra plus VGX work very nicely together and very efficiently. So here's how we segment the corporate PC world. All of us use these PCs at work, and we fall into one of these 4 categories. At the high end is the designer, the workstation user, the people that build amazing things that we use every day. So the CAD designer, the media and entertainment artist, the animation specialist, geophysicists that look for oil and gas and other natural resources. Those are the high-end guys in the designer space. And we traditionally service those with our Quadro products, our Quadro workstation type solutions. The next step down is the power user. Those are the people that use data that are created by the designers, but don't necessarily create that data. So PLM is product lifecycle management. Those are the people that access the data created by the engineers. Maybe it's a medical imaging customer, maybe not the diagnostic doctor, but the nurse that has to see the result of that diagnosis, right? So these guys are very visual in how they do their work, need some graphics horsepower behind that. The next category down is the knowledge worker. This is the mass of the market out there for work PCs. This is Microsoft Office, PowerPoint, Excel, maybe some Photoshop even. You know, the stuff that I do every day. Not exciting, but it does take graphics acceleration. Microsoft Office is a graphics application. It's not a Quadro class graphics application, but it does take graphics rendering, and that is more efficiently done on a graphics device than it is on a CPU. Right? And then task workers are the bottom of this list. Those are mostly data entry, 2D focus type things, not very graphics intensive, but that's where virtual desktops have been adopted today. Okay. So if we look at the solutions that are available for all of these users, your traditional solution, see if I can hit the button here, there we go. The traditional solution is a PC, whether it's a workstation class PC for the designer with a Quadro card in it, or whether it's a standard PC off the shelf, or even a low-end PC for some task workers. But that PC, dedicated piece of hardware, is the traditional way you service these users. When you move to the cloud, you have to have a different solution, and that's called virtual desktops. So virtual desktops today are delivered from the cloud with software rendered graphics. Right? So they use the CPU that's available in the server to render those graphics. And that's great because it's a universal resource. There's a CPU everywhere, and they can render graphics. It works. The problem is it's not efficient at rendering graphics. Right? Graphics is a highly parallel task, takes very specialized hardware. So a CPU can do that, but it takes a long time. So as long as the workload is low, it's okay to use your CPU for graphics. And this is what Citrix and VMware and Microsoft do today in the cloud. And that has been adopted and is starting to grow pretty dramatically for that task worker space, even some knowledge workers where the enterprise, the company is willing to reduce the experience level for those users. So you can do certain things like not allow your knowledge workers to install specific apps that require graphics, or turning down the level of experience in your Windows operating system. And that will enable you to deploy software rendered graphics on the CPU. But it's not a very good end user experience. Right? There's a reason that Microsoft spends all this time making the interface look really pretty. It's not just because it's pretty. It's because it helps us be more efficient, more effective at what we do. So turning those features off is really not a good answer. Okay? So we entered this market at the high end with what we call GPU pass-through. We take our existing GPUs, pass them through a hypervisor, and now you have a dedicated one-to-one model where each user gets a GPU. right? And that works great for a designer. They get the full horsepower of that GPU. They love it. It's what they're used to using on their desktop. And so it works great. Now they can access it from their iPad at home or from any of these other mobile devices. And it works great up there. The challenge is IT departments don't want to give a full GPU to your traditional knowledge worker or even your power user in most cases. Right? It's just too expensive. It's not very efficient. Takes a lot of energy. Takes a lot of power. So that model doesn't scale down very well. The software CPU rendered graphics doesn't scale up very well. So what do? We've got a gap in the middle to fill. The first way to fill that is solutions that are out there today in what we call an API intercept model. API intercept is a product similar to RemoteFX, for instance. And those use graphics hardware for the acceleration of the graphics commands. But they do what we call software virtualization. So it's a great way to put multiple users on a single piece of graphics hardware. But it doesn't scale quite as nicely as we would like to, right? So it's a good first step. What we would like to do is move this entire world to our new VGX technology. And this is true GPU hardware virtualization, right? So putting multiple users on a single GPU, just like you did with processors several years ago. So Intel with VTD, AMD with IOMMU. Now we have VGX for NVIDIA GPUs. Okay. So let me walk through how these are architected and what the infrastructure looks like for a solution. PC is fairly easy, right? We all know this one. We built these in high school when we were there. So you have a PC with an operating system. Our driver sits within that operating system, has direct access to the graphics hardware. Right? Pretty straightforward. You've got two components delivered from the graphics vendor. You've got a driver, you've got hardware. Right? Pretty easy. This is the best performance model because your driver is talking directly to your hardware, doing all the graphics rendering. Right? So now we're going to try and replace this by putting it in the cloud. Right? So today, how this gets done is we'll pick on, say, Citrix here, I think is the example. Actually, I don't have anybody named, but Citrix is one way, VMware is another way. You have a hypervisor that goes on the server in the data center. On top of that hypervisor, you build a number of virtual machines, right? And those virtual machines have some graphics commands that they need to render, so you send it to the Citrix graphics driver or the VMware graphics driver, or in Microsoft's case, the Microsoft graphics driver, right? And that graphics driver converts those commands to something that the CPU can recognize, and it executes them, all right? Works fairly well, scales fairly well, until you put a significant graphics workload on that CPU. Then it doesn't scale very well, right? So you either have to back down the number of users that you have on that system or reduce the level of experience for those users, right? So let's fix that. We're going to put a graphics device behind that hypervisor. So in your server, you install a Quadro GPU today, a VGX GPU tomorrow, and we take that GPU and we pass it through the hypervisor to the virtual machine. So now the key thing you notice here is that the graphics driver is now an NVIDIA graphics driver. It knows how to talk to the NVIDIA hardware that's underneath. Right? So it is a very efficient, very fast model for performance, for application compatibility. Right? The NVIDIA driver knows how to deal with all the applications that are out there that have a graphics API call in it. In this model, everything works. DirectX 9, 10, 11, OpenGL, CUDA will work great in this model because our driver recognizes it and talks directly to the hardware. Right? The hypervisor here gets out of the way, doesn't provide any overhead, so it's a very high performance model. Great for a remote workstation user, somebody that uses a CAD application like CATIA or NX, an oil and gas exploration application, or 3D animation. Right? If you have a server that can take a second graphics card, now you can put a second user on that same piece of server hardware in the data center. Right? So now we've got two virtual machines, each with their own dedicated piece of hardware underneath, fully accelerated. Right? You're sharing the server resources, so your CPU, your memory, your disk, all of that's being shared with both users, and you got a dedicated GPU for each user. So we see this today in the market, actually. Citrix ships this with Zen Server 6 today, and Zen Desktop 5.6 does the remoting protocol. Okay? And actually, Citrix just released Feature Pack 1 of Zen Desktop 5.6 in June. And that Feature Pack 1 has a remoting acceleration technology from us, some of our VGX remote acceleration technology that really, really lowers the latency of that remote experience. So if you've ever tried this before and didn't quite get the experience you wanted, try it again because it will be much, much better as of Feature Pack 1. Right? VMware has also announced a model here where they will do GPU pass-through and remoting with that accelerated remoting experience from us. And that will be coming soon in a version of ESX and View from VMware. All right, so here is what we call the API intercept model. So this is the attempt to fill that gap between software graphics and the GPU pass-through model. And the goal of that is to put multiple users on a single device, right? Save some cost, use a device that's appropriate for those users. So what we do is we have the hardware in the system still. We put our graphics driver this time in the hypervisor. So in Microsoft's case with RemoteFX, it's Server 2008. And so we load our graphics driver into Server 2008. And then the hypervisor vendor provides this API capture driver. So if you're using Microsoft, it's going to be a Microsoft driver in your virtual machine. So when you right-click on the desktop and say, show me the driver, it says Microsoft graphics device. Even though it's running on an NVIDIA hardware, it's a Microsoft graphics device. Okay? And what that does is it captures all the API calls. In the case of RemoteFX, it captures the DirectX 9 calls, sends those to the hypervisor, it does some management, it translates them in some cases to something that's easier to execute, and then sends it to us to do the execution. And that translation execution readback layer is the way they manage multiple users on a single device. So they'll render user 1, send that back, and then they'll look at user 2, render user 2, send that back. So this is what we call software virtualization of the GPU. And like I said, it works really well for DirectX 9 as long as the graphics workload doesn't scale really high. Because this whole process of capturing, sending it to the hypervisor, translating it, and sending it to us for execution, that takes a lot longer than the actual execution itself. Right? So you're never going to get full performance out of this model, but you do get multiple users on a single device. And this is more economical for those knowledge workers, some power users, because you can get a bunch of users on a piece of hardware that would be too expensive for an individual user. Okay, solutions that are out there today. I mentioned Microsoft RemoteFX in Server 2008. Microsoft RemoteFX in Server 2012 gets even better. They've announced that they support DirectX 11 with Server 2012. So now we get a little bit more application compatibility. No OpenGL yet from Microsoft. Certainly no CUDA from Microsoft. So if you have a CUDA workload or an OpenGL workload, it's not going to work in this situation. Right. VMware has also announced, they announced this at GTC in the US, that they will be coming out with a version similar to what RemoteFX does. And that is coming later this year, early next year maybe. Does the same thing. They have an API intercept driver that supports DirectX 9 and OpenGL 2.1. So as long as your application is one of those two APIs, it will work great with VMware's solution. All right, so now let's talk about VGX, and let's see how VGX can improve this model. We start with an NVIDIA VGX GPU. So these are brand new GPUs from us, based off of our Kepler architecture, and it's Kepler that enables us to do this virtualization. We have a couple things within the GPU itself. It's a memory management unit, and that memory management unit tells everybody where to put their stuff, right? So you take the memory, you divide it up among multiple users, and you do the page table remapping so that everybody knows where to put their things. The second piece is the dedicated channels into the Kepler GPU. This allows us to assign a channel or multiple channels to a single virtual machine so they can have direct access to that GPU. The third piece, since we put this in the data center, we can't have a DVI port on the back of it and have the user sitting there in the data center because they'd get really tired of all the noise in the data center, right? So you have to remote this. Kepler has some technologies that allow us to displayless on the card, but remote that display with very good performance. The second piece is our hypervisor. So now we have a GPU hypervisor that we build, and that gets integrated into industry standard hypervisors. So we don't replace the hypervisor, but we supplement the functionality. So now we have this virtual GPU manager. It's the one that goes in and sets everything up, says who can use the hardware when, and it passes it to our resource manager, which is the core functionality of our device. Right? And then the emulation framework allows us to let the virtual machine connect to that virtual graphics device. So now we have an NVIDIA, what we call a USM, a user selectable machine. And this user selectable machine allows the IT manager to set up a profile for each user. How much hardware resource do you have access to, right? What kind of user are you? Are you a knowledge worker? Are you a power user? Are you a Quadro workstation class user? Right? So those USMs will be selectable probably by the IT manager. Some companies will let the end user select those. Right? But that has our full driver in it, our full virtual graphics access, as well as our remote display technology in that. So now you have a native driver in the virtual machine. You have a virtual graphics device underneath that, all accelerated by the Kepler hardware. And when you have a graphics command, it goes directly to the hardware. The virtual machine talks to the hardware, and the hypervisor doesn't provide any overhead or unnecessary load on that. Once everything's rendered and ready to go, our remote display technology captures it and encodes it very, very fast, sends it out over the network. Right? So that's part of the experience. All right, let's talk about how that remote display works. Today, this is the model today without VGX. So if you have a system where you're trying to remote something, our GPU would render it, pass it to the frame buffer. Then you would do a frame buffer copy to system memory. So you take it from the frame buffer, you copy it up to system memory. That uses some CPU resource to do that copy, obviously uses system memory resource. Now you have to do a color space conversion. So we convert it from RGB to YUV, which is more friendly for remoting. That takes some CPU resource and another memory copy. So we've consumed a little bit of system memory. Right? Then you do an H.264 encode, for instance. CPU resource again. Right? You suck up some CPU resource, you do that encode, put it back into memory again. And now we pass that off to the network protocol. Okay, so all four of these steps, take CPU resource, take system memory resource, and can take a long time. Right? Typically this takes anywhere from 300 or 400, even 500 milliseconds to do all of that capture, color space, encoding, all of that takes quite a while. 500 milliseconds, that's half a second. If you click the mouse button and a half a second later something happens, by the end of the day you're going to be pretty upset with that experience, right? And you're probably not going to want to use it. Right? So we want to improve this experience, and that's what the VGX remoting technology does. With Kepler, we take the GPU rendering into the frame buffer. Now our image is sitting here on the card in memory. We have a dedicated encoder, an H.264 encoder on Kepler that goes straight from that frame buffer, does the color space conversion, does the H.264 encoding, and sends it directly to the network protocol. So it's a much, much faster process, much more efficient process as well. There's no CPU overhead here. There's no GPU overhead because it's a dedicated piece of silicon on our hardware. Right? So we've taken all that away. And the process, because it's so efficient, takes only about 10 milliseconds. So what used to be a half a second is now down to 10 milliseconds. Now you can put it on a network that may have some latency, whereas before you couldn't even use it on a no latency network. And we've seen this with Citrix and 5.6. If we compare XenDesktop 5.6 to Feature Pack 1 of 5.6, we've gone from about 500 milliseconds on a LAN to 130 milliseconds on that same LAN. So we've taken all of the upfront latency out of the equation, and we've reduced it to almost zero, 10 milliseconds. And now you can put it onto a network where there is some inherent latency. Okay, so the VGX platform really has these three components, and we've talked about those. Those are the GPU board, or the VGX board, which is the first virtualizable GPU. the GPU hypervisor, which gets integrated into an industry standard hypervisor. And this is what provides us our true virtual PC experience to the client device. The third piece is that user selectable machine. And this is what gives us our native driver within the virtual machine so that we can get full application compatibility. Right? I didn't mention, but because that driver is in the virtual machine with VGX, you get all the APIs that we support. So DirectX 9, 10, 11, OpenGL, even CUDA support within a virtual machine. And we don't have to wait for somebody else to update that driver because we update that driver constantly. And it stays up to date with the latest OpenGL, right? So when there's a new OpenGL version released at SIGGRAPH in a couple weeks, the USM and the NVIDIA driver will support that on the first day. Okay, Kepler is the key to that VGX hardware. So Kepler is the world's first virtualizable GPU at the hardware layer. And we'll bring that out in our VGX cards. The second piece is that low latency remote display that I talked about. The fast frame buffer capture and the onboard dedicated H.264 encoder. The third piece of Kepler that makes is that it's very energy efficient. Kepler's new shader model has reduced the amount of energy required per operation. Also, it's reduced the idle power draw to a very, very low level. So when you put 1,000 of these in the data center, it's going to show up whether it's an old GPU or a new Kepler-based GPU, because those are much more energy efficient, draw less power from your data center. So this is the first VGX board that we will launch. It's coming out later this year. It has 4 GPUs on it, so we put 4 of our Kepler GPUs on there, each with 4 gigabytes of memory. So it's a total of 16 gigabytes of memory on the card. And we do that because the more memory you have, the more users you can have on that card. So we showed a demo at GTC. I'm sorry I couldn't bring it here because it was a 100-screen demo. We had 100 thin clients, each with their own dedicated screen, all connected to the same server. And using this VGX card, we were able to run 100 different sessions on that single server. Right? So that's what 16 gigabytes of memory gets you, is 100 users, up to 100 users. Also has the low latency remote display capability. With our H.264 encoder, we actually have 4 of those because we have 4 GPUs. So we have 4 H.264 encoders. Each can handle multiple streams of encoding at one time. And then data center efficiency with this card. The new shader model allows us to make this a passively cooled card, which is low power for the data center. So this card, even though it has 4 GPUs on it and 16 gigabytes of memory, only consumes about 150 watts. It's actually less than this. It's about 130 to 140 watts is the typical consumption. So very low power for a graphics card. Fits nicely into a lot of servers. And I actually have one here. We haven't launched this product yet. This is the first time we've taken it outside of NVIDIA, so we were the first ones to see the new VGX graphics card. Nice, compact, tight design, passively cooled for your data center. Okay. So, and if you like afterwards, you can come up and touch it and look at it. You can't take it home because I only have a few of these in existence. So I'm gonna let you look at it, but I'll have to take it home with me because my engineers, hopefully they're not watching, are wondering where this card went because they have some work to do. Okay, so this card, like I said, is designed to fit into standard servers. This is a typical server. It's the Dell R720. Dell calls that their Swiss Army knife server. Does everything, goes everywhere. It's a great VDI server where they sell into that market today. We can take in that standard server and put not just one card, but 2 of these cards in a server. Right? So standard server by 16 slot, 150 watts with a power connector. Fits nicely into a Dell R720. Right? If you're not a Dell shop, we also have other servers that are supporting VGX cards as well. So we're working with Dell, HP, IBM, Supermicro. The new one on this list that you may not have seen before is Cisco. Cisco has never had a GPU-enabled server before. When they saw VGX, they said we should probably do a GPU-enabled server. So later this year, Cisco will launch their first GPU-enabled server. Okay, so let's, enough talking from me. Let's look at what that performance, what that experience looks like from a virtual machine served by VGX. This first example is from Autodesk Showcase. It's a 3D CAD app used for review of designs. On the left is traditional VDI, no GPU behind it. On the right is VGX accelerated VDI. And in this case, we were going to install this and run them side by side so that you can see the difference. When we went to install it, Showcase actually looks for a graphics device before it will install. And it tells us in traditional VDI, it says, oops, there's an error. I can't find your graphics device. Please tell me what your graphics device is so that we can fix that. So these types of apps won't even run in a virtual desktop environment, right? But you saw on the right, on your right, the VGX accelerated version where it runs just like it does on a normal desktop. This next example is, I believe it's the Google Earth example. So a typical knowledge worker, maybe even power user type application that we use every day. On a VGX system, it runs smooth, renders all the data that's being delivered to it. On a traditional VDI workstation or traditional VDI environment, you have to wait for the CPU to render. So it's skipping some frames, it's dropping some data, but in order to keep up, it's got to get rid of some stuff. So not a very good experience here, but on the right side, it's a typical desktop experience. You could actually use that. This happens to be our headquarters in Santa Clara. In case you've never been there, now you've been on the virtual tour. Okay, this next example, I believe, is a video playback. So we all have to watch corporate training videos or analyst videos from outside the company, right? Anything you have to do at work, maybe YouTube, right? None of us watch YouTube at work, but it does happen. On the right, fully accelerated video playback, not dropping any frames. On the left, we're dropping a whole bunch of frames because it just can't keep up by rendering on the CPU. Okay. Let me show you one more, or no, maybe two more, I think. This example is, I believe, Windows itself. So Windows Aero interface started in Windows Vista, continues in Windows 7, gets even more intense in Windows 8, has a great graphics or visual experience to it, right? So with VGX, let me see if I can play that again. With VGX, you can use all of those Windows Aero interface things. Without VGX, it won't even run. You can't do the Windows tab function in a traditional VDI environment. So you have to, IT will go in and actually turn Windows Aero off for anybody in a traditional VDI environment. All right, the last one is simple PowerPoint, your knowledge worker application. You can see the transitions between slides here are very smooth with a VGX-enabled machine. With traditional VDI, it's chunky. It's not a good experience. It doesn't look good. So if you're trying to present something, it makes you not look good being on a traditional VDI system. But with VGX, very smooth. It plays the way it was meant to be played. Okay. So that's pre-rendered video. You can believe me or not whether that's true. I want to show you how it really does work. Okay, so I'm going to, at the risk of doing a live demo, I'm going to do a live demo. And we'll see how well this works. So I think this will stay up there. Let me take this down. So this is my virtual machine sitting in the NVIDIA office down the road out here. So it's not on site. It's a couple kilometers away, or kilometer. I don't know how far the NVIDIA office is here, but it's not on site. We're connected through the network here, and this is Autodesk Inventor, so a 3D CAD app. Traditionally pretty difficult to remote this experience, but with VGX, we don't have any problems remoting this experience. It's just like a local feel. I have very good latency here, very low latency. The bandwidth consumption is actually pretty reasonable, so I can do it. As a matter of fact, I'm doing it over the wireless here. So I've got no network connection. I'm just doing it over our standard wireless here in the building, running my remote connection back to my workstation power in the data center. Right? So it works pretty good. I mean, it's not dropping any frames. It's not being laggy. I could actually work on this. If I knew how to use Inventor, I could work on this. I don't know how to design motorcycles. I'd like to tell you I did this design, but it's not mine. Right? So it works pretty good. OK, so now I'm at work. I do this work all day long, and I get this great design. And I want to go to a supplier because I need a part, right? I need a part off of this thing. I want to take it to a supplier and show that supplier. But I don't want to take my workstation with me. Matter of fact, it's in the data center, so I can't take it with me. So I just want to walk to the supplier with my tablet device, right, that I picked up at the local store. I carry this anyway to read my books on or whatever. There's no NVIDIA technology in this, by the way. We've got nothing to do with this thing. But it works great as a receiver device, as a client device for VGX. So I'm going to put it here under the camera. Hopefully you'll be able to see it side by side up here. So we are going to connect. And this is using Citrix. So Citrix receiver is available for Apple's iOS. It's available for Android. It's available for Windows and Linux and Mac. So you can pretty much install Citrix receiver on everything. So I'm just going to connect by clicking on the app here. And it's going to bring up an option to connect. So now I can go to, let's do VM2. So I'm actually connected to virtual machine 1 on my laptop here. So if I connected to it again, it would log me out on the laptop and log it in on the iPad. And that's OK, right? If I want to go use that same data set and show my supplier, that's exactly what I would do, right? I want to show you that I can actually do 2 virtual machines on the same piece of hardware. So on the same server in our data center, we've got a second virtual machine set up. And I'm going to log into that. I'm going to pull it away so you guys don't see my password. It's not my wife's name. It's not my dog's name. There we go. OK. Here we go. So now we're connecting to that second virtual machine. Same server in the data center, same piece of hardware, but we've got 2 virtual machines running, each running a 3D CAD application. I promise. It's running a 3D CAD application. Come on. There we go. Do you notice that was Windows 7? On an iPad? It's kind of not typical. We don't see Windows on an iPad very often. But if you want to use Inventor, you have to run Windows, because Inventor is only supported on Windows. So if you want to run that application, you've got to have a Windows machine. So let me see if I can drive this here. There we go. We're going to kick off Inventor, a different session of Inventor, a different virtual machine, right? This is a different virtual desktop for a different user, running, again, on the same hardware. Let's see, I have a trial application, so I'm going to say, OK, go ahead and try it. And it's going to boot up here. It's going to take a minute to start because Inventor takes a lot to load, even on a high-powered PC. There's a lot of data to load. OK, so no, I don't want any tutorials. I'm just going to open my model. And we'll try this cool-looking car thing here. OK, so this guy's still over here. He's alive. He's doing whatever he needs to do, right? Working just fine. OK. And now, what's the problem? No, we're going to skip that this time. And it's coming. Right? So now, if I'm an IT administrator, I've got 1 machine to manage, 1 OS image to manage, 1 stack of applications to manage, and a data storage space to manage. Right? So pretty simplified model, even though I'm extending it to all kinds of different cool devices, and my employees feel like they're really, really special because they get to use the latest and greatest stuff, and I don't have to support it. Right? So now we're, these cool tablet devices, everybody gets to use that. Are we loading yet? OK, there we go. I'll go away. Now, you know that the interface on an iPad is going to be difficult to use to design a product. So we don't expect engineers to design on iPads, but we do expect them to be able to show their data and their content from an iPad. So I've got the same functionality here that I had on my laptop. and I get to just play with it, do whatever I need to, select a part, right? I'm going to the wheel supplier, so I want to talk about that wheel and go to that supplier. So I'm going to just zoom in on that guy. Oops, I'm not fast enough. There we go. And I missed it, didn't I? Aren't you glad I'm not designing your car? There we go. Okay, so now we've got, I lost it. We'll rewind. There we go. Right, so now I've got two different virtual machines running, same piece of hardware. Monday morning, we hire a new engineer. We've got a third engineer. As the IT manager, I just go ahead and create a new virtual machine with that engineer's name on it. I've got the hardware in the data center already. He's off and running, right? So I didn't have to go out and buy anything new. Matter of fact, if he shows up with his own laptop, he's ready to go Monday morning without any new hardware purchase or anything on my part other than setting up that virtual machine. Okay? So that's VGX. That's the capabilities of VGX. We'll see this start rolling out over the next 6 months. So VGX hardware is not available today. A VGX hypervisor is not available today, but they're coming. So all those OEMs will ship VGX hardware within the next 6 months. We'll start seeing VGX hypervisors in the next 6 months. Citrix has announced that they will support VGX in their hypervisor coming in the next release. So look forward to that coming soon. Okay, with that, I'm going to let you go. And if you have any questions, please come up and ask. I'll hang around here for a few minutes and take any of those questions. Okay, thank you. Go this way.
以上をもちまして、グラフィックス・イン・ザ・クラウドのセッションを終了とさせていただきます。